Bismillahirrahmanirrahim. In the name of Allah, the most gracious and the most merciful. My name is Ikra Aftab, and the topic of my presentation is Review of General Properties and Periodic Trends, Distinctive Properties of the Second Row Elements. So in this lecture, we will first see the general properties of the elements that are present in the periodic table. We will see some periodic trends, and then we will see some specific properties of the second row elements. The material in this lecture is taken by the book Chemistry 7th edition by John E. M.C. Murray. It is presented by me, Ikra Aftab, and roll number is 005. So first, let's go towards the introduction. The main group elements are the 50 elements that occupy groups 1A and 8A of the periodic table. We know that the periodic table consists of many elements that are arranged in horizontal rows and vertical columns. But if we specifically talk about the main group elements, there are 50 elements that are arranged in the groups 1A and 8A. Further, they are divided into some blocks, like we have 4 blocks: S block, P block, D block, and F block elements. On the basis of block, we can say that what does it mean that the element is an S block element. For example, if first group elements are S block elements, it means that their last electron is present in the S shell. And if we say that this element belongs to the P block element, then it means that the last electron is present in the P subshell. So on this basis, the elements are divided into S block, P block, D block, and F block elements. They're divided into S block elements of group 1A and 2A. It means that group 1 and 2A are the S block elements. Their last electron is present in the S block. With the configuration, they have given that in group 1A we have 1 electron in the last shell, and in group 2A we have 2 electrons present in the last shell. P block elements are from group 3A and 8A, and their configuration is NS2 NP16. Main group elements are very important because of their high natural abundance and their presence in commercially valuable chemicals. Actually, the main group elements are naturally occurring more, so we need to study them more. That's why they are very important, and these elements are mostly taken in the reactions that we see in chemistry. 10, which are the most important or most abundant elements present in the Earth's crust. Out of 10, there are 8 elements, and out of 10, there are 8 elements that are mostly present in the Earth's crust, and all of these 10 elements are present in the human body, and they play an important role. As you can see in this first diagram, we have an earth crust, and they have given us that how much element is present in how much amount. So the element which is present in the maximum amount is oxygen, which is present in 46.1%. Then we have silicon, which is 28.2%. Then aluminium and other elements like sodium, calcium, magnesium, potassium, hydrogen. This configuration, or division of elements is present in the Earth's crust. If you talk about human body has more amount of oxygen. As you know that oxygen is essential for our survival. So oxygen is mostly present about 61%, then we have carbon 23%, then hydrogen 10%, and some other elements which are present in small amounts like phosphorus, calcium, nitrogen, potassium, sulfur, sodium, and chlorine. Now all these things tells us that why the study of periodic table is important. It helps us see that these elements are present in our daily life. So studying them, understanding their properties is very important. Next, we will see the properties and periodic trends of the elements that are present in the periodic table. The periodic trend makes it possible to classify these elements as metals, non-metals, and semi-metals. Now they're saying that some of the elements here are metals, some are non-metals, and some are semi-metals. Atoms that can lose their electron easily forms metals. Semi-metals that sometimes behave as a metal and sometimes as a non-metal, and the non-metal is opposite to that of metal. In this diagram, you can see that the ionization energy level, electronegativity level, and the non-metallic character decreases from top to bottom. What are these? That I will discuss in the next slide. And you can also see that atomic radius and metallic character increases from top to bottom. Here you can see that the elements that are in grayish color are the metals, elements in the yellow color are the semi-metals, and the elements that are in orange color are the non-metals. The ionization energy, electronegativity, and non-metallic character increases as you move from left to right. The atomic radius and metallic character decreases as you move from left to right. Here we will see and understand these behavior and these periodic trends. From left to right across the periodic table, the effective nuclear charge increases because each additional valence electron does not completely shield the additional nuclear charge. What does it mean? It means that if you're moving from left to right, the number of electrons is increasing. As the number of electrons increases, the effective nuclear charge increases. And as the electrons are increasing, the nuclear charge is not completely shielded by the valence electron. So that's why our nuclear charge is increasing. Now what happens as a result that the atom's electrons are strongly attracted to the nucleus. The nucleus attracts all these electrons more strongly. The ionization energy increases. Means what is ionization energy? Ability to remove the electron. So as the electrons are strongly attracted by the nucleus, it is very hard to remove that electron. Hence we can say that ionization energy increases. Atomic radius decreases, means the size of the atom decreases because the nucleus is holding or pulling the electron towards itself more, so the size also decreases, and electronegativity increases as the ionization energy increases. The elements on the left side of the table tends to form cations by losing electrons, and those on the right side tends to form anions by gaining electrons. Cation is formed when the electron is lost by an atom, and when an atom loses the electron, it gains a positive charge. So the elements that are on the left side mostly form cations by losing electrons, and the elements that are present on the right side, they gain the electron and form anions. And you know that anions have a negative charge. Metallic character also decreases, and non-metallic character increases as you move from left to right. Now you know what is metallic character. Metallic character means atoms behaving like a metal, as you've seen in here, that the trend that they've told is seen in this chart. Okay, this is a periodic table, and you can see that we have group 1A, 2A, 3A, 4, 5, 6, 7, 8. 8 groups that are the main groups, and in the middle, the yellow one, we have the transition elements, and the pink ones are the lanthanides and the actinides. The first group 1A is called the alkali metals. The second one is alkaline earth metals. The yellow ones are transition metals, and the green ones are the basic metals. The blue one are the metalloids. We have non-metals. Then we have halogens, noble gases, and below the periodic table we have lanthanides and actinide series that start from 57 for lanthanides and 89 for actinides. All these elements, why the lanthanides and actinide series are present below the periodic table, why they're not present inside? The reason is simple, because the periodic table was made before these elements were discovered. When these elements were discovered, if we arrange them in their places that were meant to be, then the shape of the periodic table would have been disturbed. That's why they place these groups, lanthanides and actinides, below the periodic table so that it could be arranged in a sequence. Now remember that all these elements are important to learn their properties and understand them, but the mostly that we study are the main group elements that are present in abundance. From top to bottom, if we go, now let's see the trend as we move from top to bottom. We have seen what happens when we move from left to right. Now we will see what happens when we move from top to bottom. From top to bottom, as we go, the number of shells increases as the electrons are increasing. As the shells increases, the size, or you can say the atomic radius of the atom also increases. Because the valence electrons are now far from the nucleus, they are far away from the nucleus, our ionization energy and electronegativity values decreases. Because as the electrons are far away from the nucleus, it is very easy to remove the electron. That's why the ionization energy is low. Metallic character increases and the non-metallic character decreases as we move from top to bottom. The horizontal and vertical periodic trends combines to locate the elements with most metallic character in the lower left of the periodic table, and the most non-metallic character is present in the upper right side of the periodic table. The semi-metals along the diagonal stretches across the middle. It means that the semi-metals are present on the middle side of the periodic table. Now we will see the distinctive properties of the second row elements. There are some properties of the second row elements that are different, so we have to mention them. The properties of the elements in the second row of the periodic table differ markedly from those of heavier elements in the same periodic group. It means that there are some properties of the second row elements that are different from those of the other elements present in the same periodic table. The first one is electronegativity. The second row atoms have especially small sizes and high electronegativities. This is a distinctive property of a second row element, that their sizes is especially very small and their electronegativity value is very high. The small sizes, high electronegativity make them behave as a non-metal. So the second row elements are non-metallic in behavior. Hydrogen bonding interactions is restricted to the compounds of high electronegative, which are the second row elements, especially nitrogen, oxygen and fluorine. Now we have number of bonds. Because the sizes is very small, the second row elements can maximum form 4 covalent bonds. Below you can see some examples. First we have nitrogen. Nitrogen forms only NCl3, but phosphorus can form both PCl3 and PCl5. As nitrogen is present in the second row element, that's why it can form maximum 4 covalent bonds. Okay, you can see in this diagram the 2 electrons that are present in the green shell is the lone pair of electron that is present in the nitrogen atom, and 3 bonds are formed with the chlorine atom, which is highly electronegative. And in phosphorus we have, in the first case we have 1 lone pair, but in the second case phosphorus can also form 5 bonds because it has the ability to form more number of bonds. A further consequence of the small size of carbon, nitrogen, oxygen is the ability to form multiple bonds. Okay, now they have this ability that they can form more than 1 bonds by p overlap, means they can form a pi bond. The 3p orbitals of the third row atoms are more diffuse, and the longer bond distance for these larger atoms results in poor p overlap. The distance between the bond is larger and the size of the atom is larger, so the pi bond or pi overlap is not that strong. For example, in the case of carbon, you can see the bond distance is not that much and the overlap is good. And multiple bonds can be formed readily, like a single bond, double bond, or even a triple bond in case of cyanide. But if we take silicon as an example, the bond distance is very much, and due to the bond distance is high, there is poor overlap and forming multiple bonds is very rare. Let's see the difference between the second and third row elements. CO2 is a gaseous molecular substance, whereas silicon dioxide is a covalent network solid in which silicon tetroxide tetrahedrals are linked to the four neighboring SiF4 tetrahedral by sharing the oxygen atoms. In the first structure, you can see we have an example of carbon dioxide. The black circle is the carbon and the two red circles are oxygen. Here carbon is forming a double bond with oxygen, one oxygen and a double bond with the second oxygen. So total is forming a 4 bonds, 2 with one oxygen, 2 with other oxygen. But in case of silicon, we can see that there is a covalent network structure and a tetrahedral shape is formed, and the silicon is forming further bonds again more with the SiO2 compound and forming a bigger structure. Glass made of silicon dioxide is attacked by hydrofluoric acid with formation of SiF6 negative anions. So it's just an example that the glass which is made of silicon dioxide, if it is reacted or attacked by hydrofluoric acid, then SiF6 negative anions are formed. This is the structure version of SiO2 which was also given in the previous slide. That's all. We have seen the periodic trend, we have seen a periodic table, we have seen some distinctive properties of the second row elements, and all these properties gives us the view that how the elements behave, how the second row elements have different properties from the other elements because it has very small size, the electronegative behavior, how many maximum amount of bonds can be formed. All these trends are very important. We have also seen that the main group elements are the elements that are most abundantly present in Earth's crust and in the human body. Thank you, that's all.